So the story goes that this curve is so important. It's amazing how we invented it. It's almost as if it's not clear to me whether humans invented the curve or the curve invented humans, because it's responsible for so much work from some of the most top-rated mathematicians that ever lived. Greatest curve ever. Let's take a look. So it's called the cycloid, and it goes something like this. I've got a little demonstration here. Let me zoom you in there so you can see. You see that? So what happens here is you start off with a wheel here, and you attach some sort of pencil or chalk. In this case, we're putting some red chalk on that part of the circle. Keep that attached on the circle, but then make the circle spin and trace out the curve that it makes. It will go something like this. And that turns out to be the most amazing curve in the world for so many reasons. It attracted the attention of some of the most prolific and magnificent mathematicians ever. Just like that. Here are a few challenges for you. A few challenges would be something like this. Let's do with blue. First challenge is, can we write the parametric equations for the red line? Okay, that would be x equals what and y equals what. That's a nice little challenge for you. That one probably most of us can do relatively easy in 5 or 10 minutes. The second challenge, things like can you find the length of the curve? Third challenge, can you find the area under the curve? For example, how much area is in here? Well, if you could find out, it would be easy to find out that area because it's double it. Another challenge is, can you find the volume obtained by revolving one of these, revolving it, let's make it green. If you could revolve it around the x-axis, you'd get some shape that looks like this. Or you get another shape that looks like this. You get like a chorizo, sausage kind of string. Anyways, could you find the volume of the shape generated by rotating this area around the x-axis? That turns out to be a nice challenging problem. And the list goes on and on. Could you find the center of mass, x bar, y bar, for one of these regions? And some of the most amazing mathematicians worked on this. Here I wrote a list of just for fun. Some of them. We have people like Galileo. He's one of the first ones to look at this some 300 or 400 years ago. Some of his students looked at it. The great Italian Galileo from Pisa. Mersenne, the priest who was an undercover closet mathematician, and he pretended to be a priest. The great pride of France, René Descartes, worked on it. In fact, these guys fought over who had better solutions to some of these famous problems. Fermat, the legendary, worked on it. Pascal. This is like a list of who's who. Bernoulli, Isaac Newton, Leibniz. Anybody who is somebody was working on this at the beginning of the 17th century, and that's why it is responsible for so much mathematics. It really is an amazing curve. I think it did more to us than we did to the curve. So I invite you to take a moment and see if you can answer some of those questions on the cycloid, just for fun. Participate in a 300 or 400 year tradition of thinking minds. Alright, next, what shall we do next? Next we should do some calculus, yeah? Some calculus on parametric equations, such as finding tangent slopes, such as areas under the curve, such as arc lengths, all with parametric equations. Alright, come back and we'll do some more of that.